The sun is our life source, but it's also unpredictable and violent. Solar flares can unleash storms of radiation that disrupt satellites, power grids, and even astronauts in space.
Now, scientists using the Inouye solar telescope in Hawaii have captured the sharpest images ever of a solar flare and its coronal loops, zooming in on structures just 20 kilometers across on the sun's surface. This breakthrough could transform our understanding of how the sun works and help us forecast dangerous space weather better than ever before.
On August 8, 2024, the sun erupted with an X1.3- class solar flare, one of the most powerful categories. The Inouye solar telescope captured this event at the H-alpha wavelength, 656 nanometers, producing the highest resolution images of a flare ever recorded. What did astronomers see? Coronal loops, thin strands of plasma arching along magnetic field lines. The smallest of these loops measured just 21.48 kilometers wide, about the size of a major city, yet visible across 150 million kilometers of space. Hundreds of razor-thin loops were woven together above the flare's bright ribbons of energy. For decades, scientists theorized loops this small existed. For the first time, we're seeing them directly. This observation marks a new milestone in solar imaging. The sun's outer atmosphere, or corona, is a tangled web of magnetic fields. When those fields twist and snap, they release energy as solar flares. But one of the great mysteries has been, what is the smallest building block of this magnetic system? Before Inouye, the best telescopes could only resolve features around 60-70 kilometers. Now we're down to 24 kilometers resolution, more than twice as sharp. That means scientists can finally test models of how magnetic reconnection happens, the exact process that drives solar flares. It's like going from looking at a forest to suddenly seeing each individual tree. With this resolution, models can be validated against real, small-scale structures. The ability to resolve smaller scales changes both theory and forecasting, giving us a clearer path to understand how flares begin. The team used the Visible Broadband Imager, or VBI, tuned specifically to the H-alpha line of hydrogen. Originally, the scientists planned to study chromospheric dynamics with another instrument, the spectropolarimeter. But the VBI data revealed an unexpected treasure: ultra-fine coronal loop structures in stunning detail. Lead author Cole Tambury, a PhD student at the University of Colorado Boulder, called it a landmark moment in solar science. His colleague Maria Kazachenko said seeing the telescope actually perform at its theoretical limits was exhilarating. The result? Direct images of structures that were, until now, only theoretical. Why should we care? Because what happens on the sun doesn't stay on the sun. Solar flares and their companion events, coronal mass ejections, can launch billions of tons of plasma into space. When aimed at Earth, they can knock out satellites and GPS, damage power grids, disrupt aviation and communication, and even endanger astronauts. By resolving the sun's fine magnetic structures, Inouye data can refine models of how and where flares ignite, giving us earlier warnings before solar storms arrive. That means better forecasts and better protection for critical systems. The discovery also suggests that these loops might be the elementary building blocks of flare architecture. Instead of seeing just bundled strands, we're potentially observing individual magnetic loops for the very first time. This opens the door to studying not just size but shape, evolution, and the exact scales where reconnection takes place, the very heart of solar flare physics. With detailed observations, new simulations can test where and how energy releases happen. It's a step toward answering long-standing questions about our star. Every new pixel brings us closer to understanding the mechanisms powering solar storms.
From blazing ribbons of plasma to loops thinner than a hair compared to the sun's scale, the Inouye telescope is pulling back the veil on our star like never before. It's not just beautiful, it's practical. Every pixel helps us build better forecasts, protect our technology, and deepen our understanding of the universe's most familiar star. So what do you think? Are we entering a new golden age of solar science? Drop your thoughts in the comments, and don't forget to like, subscribe, and ring the bell for more cosmic discoveries. Thanks for watching, and keep your eyes on the sun, but through the telescope, not directly.